Okay. Last class we discussed about the characteristics of network-centric computing and network-centric content. So what we'll do is we will just have a recap of the characteristics what we have discussed in the last class. I will just take the characteristics one by one and we'll go through it. It's already been covered in the last class. We'll just so network-centric computing. Characteristic is most most applications are data intensive, which means that now to collect data in almost all the fields, be it engineering, be it healthcare department, be it robotics, weather forecast, okay. Any amount of research is being done and lot of information is being collected. Also, if you go through these multimedia applications as WhatsApp or Twitter or Facebook, huge amount of data is being exchanged. So it is data intensive. Okay. Virtually all applications are network intensive. So as we amount of data is being transferred from one network to another network, from the client to the server client. So for this reason, the bandwidth must be sufficient enough so that the latency is low. If the bandwidth is more, naturally the speed will be higher. The download and the uploads can happen more quickly at a faster rate. Then use of are accessed using you already know clients makes use of limited resources. Okay, Google Chrome is one of examples. Multiple applications in okay, the resources and workflow are distributed among the different applications which each other to provide the end result. Computing and communication resources. So applications, we need to make use of the resources. The resources are nothing but the CPU cycles, bandwidth, okay, the high-end servers, okay, which are used to develop and applications, and these resources are provided by cloud, depending upon the average to peak requirement of an application. Okay. The data sharing facilitates collaborative activity. There are many which common data sets. Okay, so there are huge data sets which are available, which can be used by applications of fields. Okay, so such data sets require huge storage capabilities, which is again provided by the cloud. First, a customer needs to invest in the infrastructure, which is already provided by the cloud. The resources are all provided by the cloud, and also he pays the use pay per use, okay, facility. So all this helps in reducing the overall cost. User convenience and elasticity. User convenience and elasticity, it is nothing but the ability to use the resources to handle various varying workloads. Some of the applications may require peak resources, whereas some of the applications may not require that many resources. So the resources are provided to various applications depending upon their average to peak workloads. So this is also called as elasticity, which gives an illusion that the cloud computing offers infinite resources. Okay, these were the things that we discussed related to network-centric computing and network-centric content. You can just take down this. The first one is data intensive, network intensive, the use of thin clients, which work on lesser infrastructure, make use of lesser infrastructure, workflow management as a collaboration between different applications, computing and communication resources, data sharing, cost reduction, user convenience, and elasticity. Okay. Peer-to-peer systems. This was the topic we also discussed. We'll just have a brief recap about this topic. So peer-to-peer systems are many systems which are participating in a network, all having their own set of resources. There is no differentiation such as a client or a server. So basically any system can play the role of a client or a server, and they exchange and distribute applications among each other. Okay. So let us see the few of the features or advantages or characteristics of this peer-to-peer systems. They require minimal dedicated infrastructure, minimal dedicated infrastructure. Just take down this. They require minimal dedicated infrastructure means most of the participating devices contribute for the resources. Every participating devices are having their own set of resources, which doesn't put any extra load on a particular central controller or the server. They are highly decentralized. Highly decentralized means, as I told, there is no concept of client and server. There is no load on the server, which normally happens in a client-server configuration. All the requests from the client goes on to the server. The server caters to the requests of the client. Hence, there is enough load on the server. Here, that is not the case. There is nothing like client and server. All the participating devices, they have their own resources, which is CPU power, memory, bandwidth, and they share the applications, okay, and store the applications, and hence it is an advantage compared to client and server. They are scalable. Since there are many systems, they need not be aware of the global state or the scenario. The resources are can be replicated in many devices. Resilient to faults and attacks. Since there are many devices, most of the devices are having their own set of resources. So even if one device fails, it doesn't put the system to a halt because it can be taken over by the other devices. And also all the applications, important applications or critical resources can be replicated. The critical data can be replicated in multiple systems. So if even one system crashes, the data is still available on other systems. Hence it is, you can say that it is fault tolerant. Do not require excessive network bandwidth. Do not require excessive network bandwidth. Unlike a client-server configuration, the servers require excessive bandwidth and processing power because that is the main system which is involved in the processing of the tasks. There are many clients and one server wherein all the clients request for certain operations from the server, and hence enormous workload is put on the server, because of because it has to carry out many multiple tasks. Hence the processing power or the bandwidth to transfer the data among multiple clients is the huge amount of bandwidth is required, which is not the case in peer-to-peer systems. So the bandwidth required is less compared to the client-server configuration. Shielded from censorship. They are shielded from censorship because of the dynamic and unstructured architecture. Okay? So these were some of the features that we discussed in peer-to-peer systems. It requires minimal dedicated infrastructure. They are highly decentralized. They are scalable. They are resilient to faults and attacks. They do not require excessive network bandwidth as in case of client to server architecture, and they are shielded from censorship because of their dynamic and highly decentralized unstructured architecture. Okay. And just take down these points if you have not taken it down. Then we discussed about cloud computing, an old idea whose time has come, which means that the concept was old, but now it is being used extensively everywhere. So cloud computing, an old idea whose time has come. The meaning is, the concept is old, it was thought of previously also, but now it is being extensively used in the market everywhere. Now it is become an happening technology, because many fields, be it aeronautical engineering, architecture, okay, science, agriculture, healthcare, stock market, finance, any field, cloud computing is being used. Okay. So in this we discussed about the different types of clouds. So different types of clouds. In this we discussed about the private cloud. Private cloud is a cloud which is solely operated by an organization. It is used to store the data of the organization, which is operated by the employees or the people related to that particular specific organization. So community cloud is used by many organizations, and it is normally done to carry out, say, a particular specific mission or an objective. Okay? Next, you have the public cloud. This is available to the general public to carry out their tasks. Okay. And is owned by an organization which is selling the cloud services. And fourth one is the hybrid cloud, which is a composition of two or more clouds. Okay. And just go to the next topic. So, list of reasons for the success of cloud computing. So cloud, first and foremost reason for success of cloud computing is in a better position cloud computing is in a better position to exploit recent advances in the field of software, networking, storage, okay, processor technologies, which are promoted by large IT companies, where development can take place. Okay, so this is the foremost reason. So next one is it consists of homogeneous set of hardware and software. So you know the word homogeneous means same, which is run by under a single administration. Okay, so this homogeneous set of hardware and software setup helps in security, resource management, fault tolerance, okay, and QoS. All these become less challenging in a homogeneous environment rather than a heterogeneous environment. Okay. Focused on enterprise computing. Focused on enterprise so literally it is being used by all the enterprises, be it healthcare department, be it financial institutions, be it agricultural field, be it aeronautical engineering, be it weather forecast. Literally you take any field nowadays, any enterprises, they make use of cloud computing technologies to store data, because huge amount of data is required in these fields, in the fields of research also and technology, in fields of satellite communication. So all this requires cloud computing. Illustration of infinite resources. So the elasticity feature of cloud computing gives an illusion that there is a huge, cloud provides a huge amount of infinite resources, because it makes use of the fact that the average to peak workload of different applications vary and do not occur at the same time. Okay. Upfront financial component commitment eliminates need for upfront financial commitment, because here the users need not have any infrastructure, they need not set up infrastructure, that much cost is saved, and the cloud provides all the infrastructure and you pay as you use. So this feature helps in more businesses to be set up by making use of the resources of the cloud. Okay, they need not worry about the financial commitment for setting up the resources. So these are some of the reasons for the success of cloud computing. It is in a better position to exploit the recent advances in the different areas such as software, networking, storage, and technology, wherein a huge amount of work is being carried out by the leading IT companies. Okay. It is based on a homogeneous set of hardware and software, and we all know what is meant by homogeneous, which runs under a single administration, and because of this the setup, security, resource management, fault tolerance are less challenging compared to an heterogeneous environment. It is focused on enterprise computing. Let it be any enterprise. Nowadays all enterprises are whether it is an healthcare, as I told you, satellite communication, agricultural, technology, research, they make use of this cloud computing. The fourth one is because of its elasticity feature, cloud gives an illusion of infinite set of resources because it allots resources based on the peak to average demand of the applications. And the last one, it eliminates the need for upfront financial commitment because the industry or the person starting a business need not worry about setting up the infrastructure because it is readily available in the cloud, okay, along with the security, inbuilt security features. Just taken down this. So next we'll study the obstacles in cloud computing. So when there are reasons for success, there are also few obstacles or things which we need to worry. But of course, it is being solved. Care is being taken to solve these hurdles. So let us see what are the obstacles of cloud computing. The first obstacle is availability of service. In availability of service is basically what if a service provider fails to deliver. How much can a company be dependent on the cloud? What if suddenly one day most of the data is lost? Okay. So how much trust can you have on the cloud? So there are many questions which comes to your mind whenever you work with the cloud, whenever you save the data on the cloud. Okay. So this is nothing but availability of service. To what extent you can rely on the service provider? What if the service provider fails to deliver? What if the data is lost? Okay. So there might be a large company wherein there are thousands of employees working. There are number of transactions happening in a day. There is lot of critical data which should be secured and which should be available at any given point of time. So that places a lot of importance on the cloud computing, lot of responsibility on the cloud computing and the service provider. Vendor lock-in. So normally the customer is hooked on to a particular vendor. What if he wants to switch on to another vendor? Right now it is difficult, but things are being worked upon to make this happen in a more easier way. Okay. Data confidentiality and auditability. Data confidentiality and auditability. So as we have already discussed that the security is provided by the cloud. So how much can we rely on the security? Can we be 100% sure that the data on the cloud is secure and safe? Who is going to be held accountable? So there are many issues of this nature which need to be addressed and which are being addressed. Fourth one is data transfer bottlenecks. Data transfer bottlenecks, suddenly there is a requirement of huge flow of data, and what happens if the bandwidth is insufficient? What happens if the data is not easily accessible? What if the bandwidth becomes suddenly less at a given point of time, is not sufficient at a particular given point of time? It may so happen that suddenly most of the applications begin to either send or receive or interact with each other. So there might be a huge flow of data which may give rise to a bottleneck situation. In such case, how the situation can be handled? This is also one of the major obstacles. Performance unpredictability. Can we guarantee that the performance will be always up to the mark? Because the performance depends on many factors as to how many applications are working, or the requirement is there of the peak load, how the resources are being handled, how is the demand for the resources at any particular given point of time, is the bandwidth sufficient if all the applications require bandwidth for their peak demands. Okay, so there are many factors which affect the performance. It may work well during light loads, it may work well during average loads. What happens if the scenario is peak loads? Most of the applications or customers are working at their peak loads, they demand huge resources at the same time. So how can the performance be guaranteed? This is also one, can we predict the performance? This is also an important one of the obstacles. Sixth one is elasticity. Elasticity, as we already discussed many times, is giving an illusion to the customers that the cloud is having an infinite set of resources. This can happen because the resources are divided or given based upon the average to peak demand. Okay, based upon which application has how much demand, the resources are shared among the applications. But in order to continuously monitor the demand, in order to continuously provide the resources based on the demand, we need to have newer algorithms which can run faster, which can run dynamically, okay, and which can provide better results. Okay. So basically it is the ability to scale up and down, okay, quickly. So you can just take down these obstacles of cloud computing. That is, first one is the availability of service. The second one is the vendor lock-in. The third one is data confidentiality and auditability. The fourth one is data transfer bottlenecks. The fifth one is performance unpredictability. And the sixth one is elasticity. Okay. So these are some of the obstacles of cloud computing. So before we conclude, we'll just have a recap of what all things we discussed in today's class. In today's class, we discussed about the features of network-centric content and network-centric computing. Network-centric content and network-centric computing means basically content is nothing but the data or information. Information and or data can be of many types. It can be static data or dynamic data. It can be live data. It can be stored data. Okay. So there are many types of data available which need to be processed, and we need to make it into a complete meaningful information. And most of the information is normally transmitted from one system to another, from the source to the destination, by making use of networks. And hence this network-centric content and network-centric data provides us with a lot of features. So the features that we discussed was that most of the applications are data intensive. Virtually most of the applications are network intensive. Then the systems can make use of thin clients with limited resources. Then the infrastructure supports some form of workflow management, and it makes use of computing and communication resources which are very necessary. Then data sharing facilitates collaborative activities among different technologies, because most of them might be requiring common data sets. Then cost reduction, which is possible because of the elasticity and pay-per-use feature. And finally, user convenience and elasticity. Okay, these were some of the features that we discussed in network-centric computing and network-centric content. Then we discussed about the different types of clouds: private cloud, which is restricted to an organization; public cloud, which is available to all the public, all the end users. Okay, and then we have the community cloud, which is used for a particular mission or a goal, and a hybrid cloud, which makes use of more than one clouds, more than one type of clouds. Then we discussed about the, just now we discussed about the reasons for the success of cloud with cloud computing. That is, cloud is in a better position to exploit the recent advances in different fields. Then it makes use of homogeneous set of hardware and software. Then it's focused on enterprise computing. Then there is no need for financial commitment, and it gives an illusion of infinite computing services. But along with the successes, there are certain obstacles such as availability of service, the vendor lock-in, then data confidentiality and auditability, then data bottlenecks. Data transfer bottlenecks, then performance unpredictability, and elasticity. Okay, these were the few things, obstacles we discussed. We will stop for today's class. Okay, so just to go through all the points which we have discussed, all are important. Already I have provided you with the notes and the PPTs also. You can make use of them along with these lectures. Okay, thank you.